Alright, in this section I have quite a bit to talk about, and it is dealing with concavity in the second derivative. I'm first going to define being concave up as somewhere on the interval where f prime of x is increasing. So if I extend this out just a little bit more, f prime of x would be a negative number, and then it's less negative, then it's 0, then it's more positive. So you can see how f prime of x is increasing. So concave up looks like this. If the derivative of the function is decreasing, so here it's positive, then it's 0, and then it starts becoming negative and more negative, so f prime of x is decreasing on that interval, then I know it's concave down, and this is what concave down looks like. Going a little bit further into this, I wanted to show you another picture. Interval A to C, the open interval A to C, is concave down. How you can remember that is it won't hold water. From C to E, it's concave up, and it will hold water. The point of inflection, so where it changes concavity. Let's write that in there. This is where it changes concavity. Points of inflection. So we have critical numbers that we look for when we're increasing and decreasing, and now we have points of inflections. Points where things could change. Could, this is a key word, from concave down to concave up, or concave up to concave down. How we're going to determine whether it's concave up or concave down is by looking at the second derivative. If the second derivative is positive throughout an interval, then we're going to say it's concave up. If the second derivative is negative throughout an interval, then we're going to say it's concave down. So this one was negative, this one was positive. So if it's positive, it's concave up. If it's negative, it's concave down. And the other thing we're going to take note of is that f double prime, if it's equal to c or if it's undefined, then there's a possible point of inflection. Possible. It doesn't have to change concavity, but sometimes it does. What we're going to do is we're going to practice drawing a few of these things. We're going to draw a decreasing function that is concave down. So what I'm going to do is kind of just sketch here. Decreasing would look like this. Now I want it to be concave down, so that's going to not hold water. So I'll put a dot right here, and then I'm going to make it stay decreasing, but notice how it's concave down. This wouldn't hold water. If the water hit it, it'd run off. A falling function that's concave up. So a falling function would look like this, okay, but if it's concave up, it's going to hold some water. Okay, so it's falling. This is concave up. It wouldn't hold a lot of water, but it would hold some water. An increasing function that is concave down. So increasing means it's going to be going up like this. Concave down, it won't hold any water, so it's got to be curved like this. Going on a few more of these. An increasing function that is concave up. So we've got increasing again, and we want it to be concave up. So we will have it holding water. The number 5 says, let's sketch something that is, this means increasing, right? Greater than 0. The first derivative is greater than 0 everywhere. So it's increasing everywhere, but the second derivative, remember, applies to concavity, and it's concave down everywhere. So we want it to be increasing everywhere, but concave down everywhere. So we could just create a function that looks like this. It's increasing, but it's concave down everywhere. The last one of these sketching says that we're going to create a graph that is increasing with a point of inflection at 0, 0. So I'm going to go ahead and just start to draw this graph. I've got 0, 0 as a point of inflection, meaning it's either changing from concave up to concave down or vice versa. Right here it tells me this is concave down because it's less than 0. And this means concave up because it's greater than 0. So when it's less than 0, I want it to be concave down, so I'll make it look like that. That would be concave down. And then at 0, it changes and it becomes concave